Assalamualaikum and hi. In this video, we are going to summarize laboratory experiment for experiment 1, Coulomb's law by Shafia Amira Ismail, experiment 2, Capacitance by Cik Wan Nur Afifah Husna Cik Wan Jaafar, experiment 3, DC circuit by Anis Munira Rosli, and the last one is experiment 4, Magnetism by Johanna Johari. Feel free to watch our video, hit the like button, and don't forget to subscribe.
Hi and Assalamualaikum. My name is Shafia Amira binti Ismail. I am the first presenter. So, I will present about the first experiment, which is Coulomb's law. Let's begin. First of all, in the beginning of this experiment, we must know the objective of this experiment, which is to satisfy the Coulomb's law experimentally. Second, to study the parameters that affect the electric force. And the last one, to find experimentally the electric constant, which is K. Then, the procedure of this experiment: first, we need to click the link that given in the lab manual, and then an image will be displayed like in the bottom of this slide. There are two parts in this experiment, which is part A and part B. First, for the part A, we're gonna fix the charge in the beginning of this experiment. There are two charges, and we have to change the distance between the charge between 3 until 10 to find the rate of the distance and the electric force. And then after get the result, we must record in the table given. Then for part B, we have to fix the charge 2. Then we need to control charge 1 and the distance between two charges as 5 microcoulomb and 6 cm. Then there will be charge in charge 2. It is between 10 to 3 to find the electric force. From this experiment, we will find the result of this experiment, which is the electric force versus the distance. Here we know the higher the distance, the lower the electric force. Meanwhile, for this graph, it is shown that the graph between electric force versus the rate of the distance, we can see that the higher the rate of the distance, the higher the electric force. For the result part 2, we can see that the graph shows for electric force versus charge. From this graph, we know that when charge increases, the electric force also will be increased. Now, we will discuss about the error and the precaution that will occur in this experiment. Firstly, the error in this experiment is misreading data on the measurement. This is because when the measurement do not parallel to the reading scales. Secondly, high voltage at the terminals of the supply can also cause leakage current. For the precautions of this experiment, we must make sure the reading scale is parallel to the object we conduct to take the exact amount or value. Secondly, stand at the comfortable distance away from balance in taking the measurement in order to minimize the effect of static charge. As a conclusion, we can conclude that Coulomb's law is the electric force between two charges is proportional to the product of the charge, and then it is inversely proportional to the distance between them. More than that, we can conclude that electrostatic force can be decreased and increased depends on the charge, while distance between two charges is constant. So, that's all from me for the first experiment. Thank you.
Hi, my name is Cik Wan Afifah Husna binti Cik Wan Jaafar. Now, I'm going to present the second experiment, which is capacitance. The objective for this experiment are to study the capacitance varies with the area of the plates, to study the capacitance varies with the separation between the plates, and to study the dielectric effects on the stored charge, energy, and voltage between the plates of the capacitor when it is connected or disconnected from the battery. There are two parts in this experiment. Now, I will explain about the part 1 for this experiment, which is capacitance. The picture shows the setup for this experiment. For the procedure, we start by click the link given, then from the list of the electric, choose paper from the menu on the right side, then insert the dielectric completely inside the capacitor. Check the capacitance to see the capacitor meter. The battery for this part could be either connected or disconnected. Record the values of the plates area, distance between the plates, and corresponding capacitance. Slowly increase the plates area and measure the corresponding capacitance 4 more times. Record the result in the table and use SI units for all measurements. Restore the area to inertia and slowly decrease the separation between the plates. Measure the corresponding capacitance 4 more times and record the result in the table along with the reciprocal of the separation. Now, we go to the next slide. It shows the table for the result and also the graph. Based on the graph, it shows that the capacitance is directly proportional to the area of the plates and the reciprocal of the separation between the plates. Next is the part 2 for this experiment, which is the effect of the dielectric on capacitor. The pictures in the slide show the setup for this experiment. Now, let's get through the procedure for part 2. This experiment starts with revert the values of the plate separation to the original and remove the dielectric entirely from the capacitor. Show the capacitance, charge, voltage, and energy meters by taking off approximate box on the right side of the simulator. Connect the voltmeter by place the electrodes on the plates. Connect the battery and turn on the battery voltage to about 1 volt. Slowly insert the dielectric inside the capacitor. When the dielectric fills more space in the capacitor, observe and record the change in capacitance, charge, voltage between the plates, and energy stored by the capacitor. Lastly, remove the dielectric entirely and disconnect the battery. Repeat step 3 and record the change in capacitance, charge, voltage between the plates, and energy stored by the capacitor. In the next slide, we can see that the result for the connected battery, the only thing that remains constant is the voltage between the plates. Meanwhile, for the disconnected battery, the charge remains constant. For the discussion, we get to know that the energy of capacitor battery system conserved throughout the process of inserting the dielectric when the battery is connected. This is because the voltage between the plates remains constant while the capacitance, charge, and energy stored by the capacitor are increasing. Next, the energy stored in the capacitor does not remain constant as the electric is inserted when the battery is disconnected. The only thing that remains constant when the battery is disconnected is the charge. The first graph shows that the capacitance is directly proportional to the area. Meanwhile, the second graph shows that the capacitance is directly proportional to the reciprocal of the separation between the plates. There is an error that commonly happens during the experiment. It is possible to have an inaccurate data, so for the improvement, the process of reading and recording the data must be made several times to get the precise reading. Lastly, for the conclusion, based on the graph, the capacitance of a parallel plate capacitor depends on area of the plate and the separation between the plates. When the area of the plate increases, the capacitance increases. When the separation between the plate decreases, the capacitance increases. The dielectric constant for this experiment is 3.47. Meanwhile, the percentage error for this experiment is 0.86%.
Hi, I'm Anis Munira binti Rosli. I'm going to summarize experiment 3 DC circuit. There are 3 objectives in this experiment. Number 1, to measure the current and voltage for a simple DC circuit. Number 2, to study series connection of resistors. And the last one, to study parallel connection of resistors. There are 3 parts in this experiment. Part 1, measuring the current and the voltage in simple DC circuit. Part 2, series connection of resistors. And the last one is Part 3, parallel connection of resistors. For experiment Part 1, a series circuit that contains a battery, resistance, voltmeter, switch, and wires was constructed as follows. An ammeter was then dragged to the circuit. The voltage of the battery was adjusted to be 10 volts, 20 volts, and 30 volts. The current I1, I2, and I3 was measured and the result was recorded in the report. For experiment Part 2, a series circuit that contains a battery, two resistors R1 and R2, voltmeter, ammeter, switch, and wires was constructed as follows. The power supply output was adjusted to 120 volts, while the two resistors were adjusted to be 20 ohm and 30 ohm. The electric current I was measured using the ammeter before R1, between R1 and R2, and after R2. The result was recorded in the report. For experiment Part 3, a parallel circuit that contains a battery, two resistors R1 and R2, voltmeter, ammeter, and wires was constructed as follows. The voltage of the battery was adjusted to 120 volts, while the two resistors were adjusted to be 20 ohm and 30 ohm. The current I1 through resistance 1, the current I2 through resistance 2, and the total current was measured. The result was recorded in the lab report. The results for experiment Part 1, Part 2, and Part 3 are as follows. For Part 1, the graph of voltage versus resistance has been plotted. For Part 2, the graph of voltage versus current has been plotted. And the last one, for Part 3, the graph of the total voltage versus the total current has been plotted. For experiment Part 1, this experiment obeys Ohm's law formula, which is V equals to IR, where the current through a conductor between 2 points is directly proportional to the voltage across the 2 points. For experiment Part 2, the sum of voltage V1 and V2 equal to the total voltage across the resistance R1 and R2 because the formula for the total voltage in a series circuit is V total equal to V1 plus V2. The current I before R1 equal to the current between R1 and R2 and the current after R2 because the electric current in a series circuit are always equal, where I total equal to I1 equal to I2. I product R1 equal to V1 and I product R2 equal to V2 because this experiment obeys Ohm's law formula, which is V equals to IR. For experiment Part 3, the total voltage in a parallel circuit is always equal, where V total equal to V1 equal to V2. The sum of I1 and I2 is equal to the total current in the circuit because the formula for the total current in a parallel circuit is I total equal to I1 plus I2. In the end of this experiment, we can conclude that the experiment was successfully conducted because the current and the voltage of a simple DC circuit can be measured by using Ohm's law formula, which is V equals to IR. The voltage and the current of the series and parallel circuit were successfully observed by connecting the ammeter and voltmeter in the circuit and using the formula for series and parallel connection.
Hi and Assalamualaikum. My name is Johanna binti Johari, so I am the last presenter for this presentation, and I'm going to be presenting the fourth experiment, which is magnetism. As usual, before we start our experiment, we must find our objective. So the objective of this experiment are to study the magnetic field and to determine the relation between the amount of field strength and current. Since we are doing this experiment through a simulation, so we need to click and open the link given in the lab manual. Then a simulation from magnetism experiment will appear in a short while. So, looking for a bar magnet simulation, firstly, the compass was moved around the bar magnet to see which pole of the magnet does the red compass needle point towards to. Next, the polarity of a bar magnet was flipped to see is it the red needle of compass still point towards to the same pole or not. Thirdly, there is a blue box which is the field meter. This field meter was moved around the magnet to observe whether the magnetic field increases or decreases as the field meter was moved closer to the magnet. Then, the field meter was moved about 1 inch away from the north pole of the magnet, and the magnitude of the field strength was recorded. Do the same thing on the south pole of the magnet and see is it the amount of the magnetic fields are same or not. Moving on to the electromagnet simulation, the compass was also moved around the electromagnet to see which pole is the left side of the electromagnet. Repeat the step number 2 with the side of the electromagnet and see is it the field strength increase or decrease as the meter was moved closer to the electromagnet. Next, adjust the number of lobes in the electromagnet and record the field strength. And lastly, set the number of lobes for the electromagnet back to 4 and adjust the voltage in the electromagnet from 0 until 10 volt and record the field strength. Moving on to the presentation of data. So, the first table is showing the effect of different number of lobes towards the field strength produced. The result shows that the higher the number of lobes, the higher the field strength. While the second table is showing the effect of different voltage towards the field strength produced. The result shows that the higher the number of voltage, the higher the field strength. So, from the experiment, we can conclude that the red needle's compass point towards to the south. A magnetic compass does not point to the geographic north pole. A magnetic compass points to the Earth's magnetic poles, which are not the same as Earth's geographic poles. Furthermore, the magnetic pole near Earth's geographic north pole is actually the south magnetic pole. So, when it comes to magnet, it will repel each other. Next, the relationship between the magnetic field strength and distance is as the distance increases, the magnetic field strength decreases. This is because of the inverse square law. An inverse square law is any scientific law stating that a specific physical quantity is inversely proportional to the square of the distance from the source of that physical quantity. Last but not least, as we conduct the electromagnet experiment, when moving the compass, we get that left side of the electromagnet is the south pole. It is because the north pole of compass magnet is the north seeking end. So when it is moved to the left side of the electromagnet, the north pole of the magnet is pointed to the opposite way. By doing this experiment, we can conclude that the magnetic field is a vector field of a magnet, electric current, or changing electric field which magnetic forces are observable. Magnetic field causes the electricity charged particles to travel along a circle or helical direction. We can also determine the relationship between the amount of field strength and current, which is the strength of magnetic field is directly proportional to the current flowing. Therefore, if an alternating current is flowing, a magnetic field around the conductor will be produced. That's all from us. Thank you for listening and have a good day.